All right, we are recording.
Hello, my name is Barber. These are my partners, Brightwell and James Richardson. Today we're going to be going over some of the forms of internal corrosion. The forms we're going to cover today are corrosion fatigue, intergranular corrosion, transgranular corrosion, liquid metal embrittlement, selective leaching, and will decay. Corrosion fatigue, the definition of corrosion fatigue is the result action of combined alternating stress cycles and being in a corrosive environment. Environments, one of the most common environments of corrosion fatigue would be in a steam boiler, because the heat from the steam is accelerating the corrosion rate, and also the pressure from the steam is increasing the fatigue. Just basically anywhere that there's a corrosive solution under a load stress. Examples would be a vac truck with salt water or brackish water in it. Just the weight of that corrosive solution in that tank, and it's probably going to be down a dirt road somewhere, so it's going to be, sloshing back and forth in the tank, transferring, the weight, and just causing fatigue on the structure that's holding it, and just being the corrosive solution that it is. And susceptible materials, steel and any engineering alloy metals. Mitigation methods. It can be prevented by using high-performance alloys that are resistive to corrosion. They're a little more expensive. CP systems are useful, and aqueous solutions. And under ideal conditions, using CP can increase the fatigue limit. It means it'll hold more load stress and cycle stress. Monitoring and testing, cycles to failure test. This testing method, it tests parts or piece of the material subject to a significant number of stress cycles, which means when they test it, they put a stress on it, and they elevate it, and they increase it and decrease it until it creates a crack. And they keep doing it until the crack is a complete fracture. Crack. Propagation testing is a testing method. It's more of a mechanical method. It's used to determine the crack growth. So if there's already a crack there, it's going to measure how big the pre-existing crack is under cycle stress. Pre-existing cracks or sharp defects in the materials reduce the crack proportion of the fatigue life of the component. Mechanisms. The cracks can be intergranular and change to transgranular. The pitting corrosion intergranular corrosion are generated alternately to indicate corrosion fatigue cracks. The multiplication and pileup of dissolutions due to the application of cycle stress promote the pitting and intergranular corrosion. And that's a picture of some corrosion.
There's a difference. Right here is where the main difference is in the different types of cracks, and you'll see that in the future slides.
Now Zach's going to go over some of the
Selective bleaching.
bleaching.
It's also referred to as de-alloying, where one element is taken out of the alloyed metal environments. This dezincification, it happens in water of stagnant conditions. Denickelification happens in heat flux and low water conditions, and graphitization happens in soils, waters, and environments containing chlorides. mechanism. Different metals and alloys have different corrosion potentials in the same electrolyte. The potential difference between the alloying elements is the driving force for the preferential attack on the more active element in the alloy. Examples. Dezincification is where the zinc is selectively removed from copper zinc alloys. Graphitization is the decomposition of iron carbide at elevated temperatures. Susceptible materials, dezincification, unstabilized brass, denickelification, nickel, and graphitization. Gray cast iron, such as cast iron painting. Monitoring and testing. Visual inspection if in atmospheric environment. Mitigation methods to use sacrificial anodes or infrared current cathodic protection, control the environment, or selection of material that may be more resistant to de-alloying. And here you can kind of see kind of how it happens, I guess. Here as well.
Okay, the next one's fatigue. The term fatigue is based on the concept of material that becomes tired or fails at a stress level, lower than the normal strength of material. So after a material is used and has been in work for a while, and the stresses of the work, the stress load, it increases, it fluctuates back and forth, which, in turn, which makes the material more weak, and it ends up failing at a lower level of stress than it was said to be okay with. Mechanisms, failures at lower levels of stress if a force is constantly applied or withdrawn. Vibration produces fatigue stress too. Examples would be a leaf spring flexing up and down from everyday driving, a bolt that holds something together has repeated stress. Susceptible materials, spring steels with carbon content anywhere from 0.35% to 1.4%. The environment, structures or a part dealing with repeated loading and unloading. Environments where there's heavy vibration. Monitoring and testing. In some cases it can be seen with the naked eye. Sometimes you can see if it's a big enough crack or something from the fatigue. You can just see that with your eye. Non-destructive test methods are used to detect and determine the severity of the area of fatigue. Mitigation methods, engineer design.
And you see how this one doesn't have the, I guess you could say the forks or whatever. It doesn't split whenever it comes down any like the corrosion fatigue does. And here's more examples of it.
All right. Transgranular corrosion. Definition of transgranular corrosion is a preferential corrosion that occurs across the grain boundaries of a metal, also known as transcrystalline corrosion. The environments that you can find transgranular corrosion are in areas where stress is present from the result of weight, specifically heavy weight. It is often found in environments where chemicals such as ammonia and chlorides are present. Examples is stress corrosion cracking. The mechanism is it occurs where metals may be absorbent and collect certain species of chemicals such as microbiology influence corrosion, also known as METL for short. Other foreign objects like dirt or debris from the result of a metal not being cleaned properly or welding is performed. Vibrations while under extreme weights or force is being applied. Ways to monitor and test transmitting corrosion is testing is only corrosion test performed as a standardized pre-delivery test. The straws, Huey and Strifer are the common test methods. Susceptible materials are aluminum alloys such as chlorides, moist air, magnesium alloys, chloride chromate mixtures, moist air, copper alloys, ammonia, moist air, carbon steels, nitrates, hydroxides, and carbonates, and high-strength steels, most air, water, and chlorides. Mitigation methods, ways to try and prevent transmitting corrosion are avoiding areas with high chloride and ammonia chemicals. Utilize materials that are less corrosive in certain environments, and controlling temperature during the alloy process of the metals. Here you can see an example of the grain boundaries on this metal, and it cuts across instead of going inside of the grain boundaries. And here's an actual picture of a piece of metal where it looks like a tree branch. And we got one more picture here. This is a side view x-ray. You can see here where how it breaks down into the grains of the metal.
Integrating of corrosion. The preferential corrosion at or along the grain boundaries of a metal. In the environments that you find it in is areas of welds may be improperly prepared prior to welding. It may occur where vibration is repeatedly occurring under pressure or stress members of the metal. Examples, stress corrosion cracking, that's what it's commonly called or found to be. The mechanism results from local differences in composition, such as coring commonly encountered in alloy castings, and monitoring and testing. Testing is the only corrosion test performed as a standardized pre-delivery test. Strauss-Hughes and Strasser are the common test methods. Susceptible materials, metal that may have been heated for too long during the metallurgy process, and alloys have possibly evaporated out. Mitigation methods, use stabilized metals like titanium or niobium when alloying the steel with steel. Use post-weld heat treatments. Use low carbon grades of steel such as stainless steel. And then here you can see how the cracks are going along grain boundaries versus through the grain boundaries.
Okay, liquid metal embrittlement. Liquid metal, also called as LME, refers to the environment cracking caused by contact with a liquid metal. Environments where metal is liquefied and becomes brittle. The mechanism of liquid metal cracking is not electrochemical in nature. It is absorption included induced cracking. Liquid metal atoms, when absorbed on a susceptible metal or alloy, reduces the metal bond and forces it to crack. And the strength within the grain boundary regions of the susceptible metal under tensile stresses cracks, initiates, and propagates rapidly along the grain boundaries. Examples: Copper and copper alloys are susceptible to liquid metal cracking by mercury and lithium. Susceptible metals, carbon steels and stainless steels are susceptible to LME by zinc and lithium. Aluminum and aluminum alloys are susceptible to LME by mercury and zinc. Monitoring testing, you can slow the strain rate testing, SSRT, and mercury for screening. Fitness for service testing based on constant deflection testing in a simulated service environment. Ways to mitigate liquid metal embrittlement are to avoid contact with or contamination by the crack causing liquid metals. Do not use low melting points metals near the melting points, and use metallic coating and cladding as a barrier protection. Here you can see where a metal has fell into another metal and started to crack and go into the grains of the metal. That's the side view and that's the top view. Here's another picture that demonstrates that. Weld decay and sensitization. Weld decay is intergranular corrosion, usually of stainless steel or certain nickel-based alloys. That occurs as a result of sensitization in the test effective zone during the welding operation. Sensitization, however, is where the heat during the welding processes cause the participation of carbides at the grain boundaries, often causing the alloys to become susceptible to intergranular corrosion and intergranular stress corrosion cracking. Environments can be in soil or aqueous conditions, can be in atmospheric conditions, and conditions that could help speed up the process could be areas of high temperatures and rich in chlorides. Mechanism: participation of chromium carbides is induced by the welding operation when the heat effective zone experiences a particular temperature range, and that range is 122 degrees Fahrenheit to 1562 degrees Fahrenheit. The precipitation of chromium carbides consume the alloying element chromium from a narrow band along the grain boundary, and this makes the zone anodic to the affected grains. The chromium depleted zone becomes the preferential path for corrosion attack or crack propagation if under tensile stress. Examples: buried pipeline where the joints are welded together. Above ground storage tanks where the plates are welded together to make the tank. Mitigation methods: the way to prevent this is to use post-weld heat treatments on your welds, using laser beam surfacing, and using low hydrogen welding rods. Susceptible materials: this process mostly occurs in stainless steels or certain nickel-based alloys. It is a form of intergranular corrosion. The best way to test for this is X-raying the weld joints and using strength tests after welds have settled. And here you can see where this weld to this joint started to decay. And right here is right in here is where it started to decay also. If you go to the next slide. See how it's all really dark in there? That's where the sensitization, where the heat affected this zone and causing it to decay there.
That's our references where we found all our information, and that's all for our PowerPoint presentation. Y'all have any questions? All righty, thank you.